Okay, welcome back to the SBI 4U lecture series. Today's lecture is titled Functional Groups. So as we know, and have discussed in class, all life as we know it is based on the atom carbon. Carbon has four electrons in its valence shell, and it will form, therefore, four covalent bonds with other atoms. Because of these characteristics, carbon forms the basis for sugars, lipids, proteins, and nucleic acids, which are the main macromolecules that we're going to look at in this course. So carbon makes up much of the mass in sugars, lipids, proteins, and nucleic acids. Because of this, carbon tends to bond in different ways with different atoms, and therefore we have what are called functional groups. Functional groups can be considered bondings of atoms with larger carbon molecules, and they're usually strongly polar, and they cause various carbon molecules to behave in different ways. So let's take a look at some of these functional groups, and what we're going to do is make a little bit of a table in your notebook now. We'll have the functional group here, and then we'll have an example of that molecule. So the first functional group I want to look at is the hydroxyl group, and that hydroxyl group has a standard look of a carbon molecule, carbon atom bonded to an OH, an oxygen, and a hydrogen. And this class of molecules is generally considered to be alcohols. And a perfect example of alcohol is the very common ethanol, or ethyl alcohol, and that is seen with two carbons, an alcohol or a hydroxyl group, and the rest of the carbon bonds filled in with hydrogen. Okay, this is called ethyl alcohol, and that's the alcohol of alcoholic beverages. The next functional group I want to look at is called the carbonyl groups, and there are two of these that we're going to look at. The first of these has a shape that is two carbon atoms, well, one carbon atom double bonded to an oxygen molecule in this configuration, and the other one has a carbon molecule double bonded to an oxygen in this configuration. There are two different names for these subclasses. This is an aldehyde group, and these are considered to be ketones. An example of an aldehyde you can consider to be acetaldehyde, and the example of a ketone that we will look at is called acetone, and it can be seen in this three-carbon molecule. You'll notice that with acetone, I haven't drawn on all the H's. You'll find that sometimes when drawing in short form, we leave the H's off, and it just makes the molecule a little bit simpler. The third functional group that we're going to look at is the carboxyl group, and these are considered to be a class of molecules called organic acid. The chemical model for this is a carbon atom double bonded to an oxygen and then double bonded to an OH group. Okay, so this is your general form for an organic acid. This will become very common to you, and we'll use this quite often. Probably the simplest example of this is vinegar, which is a two-carbon acid, and it's called acetic acid. The group we're going to look at are called is the amino group, and the amino group is found in a class of molecules that are most commonly called amino acids. These are going to be very common and very important when we start to look at proteins. The amino group has a molecular shape, or you can tell the amino group as it's a carbon atom bonded to an NH2 molecule, or it can be drawn as the structural molecule of N and two H's coming off it like that. Okay, very common in amino acids, and you could see this as an example in the amino acid alanine. So as you can see, this is the amino acid alanine. It has the amino group here, amino, and it has the organic acid group here. This part of an amino acid is extremely important. It's another grouping on the amino acid, and this determines how the amino acid behaves and what kind of an amino acid it is. When we get into proteins, we're going to talk about that a little bit. Okay, our next functional group are called phosphates, and these are a big bulky molecule that ends up looking like this. It's got a carbon bonded to an oxygen, bonded to a phosphate with another oxygen, and another oxygen coming off it. There are negative charges on these oxygens, which means that it becomes quite polar, and it has a lot to do with the bonding and structural stability of certain molecules. Those certain molecules are most readily exampled in this course as being nucleic acids. And so those are things like RNA and DNA. And the last functional group we're going to talk about in this course is the sulfhydryl group. And this molecule ends up looking like that. So it's a carbon bonded to a sulfur with another hydrogen on it. And this functional group causes much of the structural formation of proteins, and we'll discuss sulfhydryl groups and sulfur bridges more when we look at some of the structures of proteins. So the question becomes, why look at functional groups? Well, functional groups act as a handle on organic molecules. So let's look at an example here. If we were to look at a molecule called ethane, like this, 2 carbons bonded together with 3 hydrogens coming off each of them, and we were then to look at ethanol, which is very similar, except that it has a hydroxyl group coming off the end of it. We find that ethane is not very soluble at all in water, while ethanol is actually miscible in water, and you can mix it in water with as much as you want. So it's a miscible liquid. Because of this OH group, water is attracted to it, and therefore the solubility increases greatly. And as I mentioned, the solubility of a molecule impacts its biological activity.